This video lecture addresses wastewater treatment. The aim in wastewater treatment is to reduce organic matter and reduce biological threats to downstream systems. When tertiary treatment is employed, the aim is also to reduce nutrients to downstream systems. There are three stages in wastewater treatment, that is, primary, secondary, and tertiary or advanced treatment. In primary treatment, screens and settling tanks remove grit and suspended organic matter. Although sometimes pretreatment is used to remove the largest debris and slow the flow of the incoming water. Secondary treatment is when the wastewater is aerated, which facilitates aerobic bacteria in consuming organic matter. Recall that aerobic bacteria work more quickly than anaerobic bacteria in breaking down organic materials. Although this process breaks down organics, it leaves dissolved inorganics like nitrate, NO3, and phosphate, PO4. These nutrients are concerning for water discharge as they facilitate biological productivity and eutrophication. The final step is called tertiary or advanced treatment. This step filters most dissolved inorganics and remaining dissolved organic compounds, providing for low nutrient waters for downstream discharges, deep well injections, or other means of disposal. For a closer look, primary treatment includes screens and settling tanks, remove grit and suspended organic matter. As Anderson and Sheffield note, many facilities have primary clarifiers or sedimentation tanks. In this sedimentation stage, water slows down and large debris settles out due to the forces of gravity. That is, when the velocity of water drops, materials are no longer carried in the flow and settle out of the water column. Materials less dense than the water will float to the top and can be skimmed off, whereas heavier sludge can be collected from the bottom. Any large debris can be dried and disposed of in a landfill or through land application. The clarified water then flows to the secondary treatment phase. For a closer look at secondary treatment, three common steps include an aeration basin, a secondary clarifier, followed by filtering and disinfection. In the aeration basin, oxygen is added into the water column, generally through agitation or a waterfall. The high dissolved oxygen levels in the water column promote aerobic bacteria breakdown of the organic wastes. The secondary clarifier works in the same way as the primary clarifier, where solids are collected at the bottom and less dense materials like oils and grease are skimmed from the surface. The clarified water then moves through filtration using coal for its organic properties and sand. Finally, water is disinfected through one of a variety of processes. In the U.S., we see a lot of chlorine disinfection, ultraviolet light disinfection, or ozone. As noted in the graphic, sludge collected through clarification and settling is often digested, composted, and then sent to agricultural lands for land application. In some cases, cogeneration may occur, where off-gases are used for electric generation or other uses. After aeration, secondary clarification, filtration, and disinfection, the water has completed secondary treatment, can either be moved into tertiary or advanced treatment, or be discharged into waterways. Keep in mind that at the end of secondary treatment, nutrients have not been removed from the water stream, so that dissolved inorganics remain in the water stream. Tertiary or advanced treatment is not required through regulation in all cases. This phase can be done biologically in natural or artificial wetlands or through combined processes in a more traditional treatment facility. Tertiary treatment aims to filter most dissolved inorganics and remaining dissolved organic compounds, which will greatly contribute to improved water quality in receiving systems. Wetlands are used frequently to polish the secondary treated water and act as a natural nutrient sink, and in some cases as secondary treatment, where water can be aerated and natural biological and chemical processes can treat the organic wastes. From coast to coast in the U.S., for example, from Orlando, Florida to Humboldt, California, we use wetlands As an example, the Arcata Wastewater Treatment Plant in California uses traditional primary treatment depicted in dark blue in the graphic, followed by a treatment wetland for secondary treatment depicted in dark green in the graphic as described by the Environmental Resources Engineering, Humboldt State University, no date. The intent of secondary treatment, which uses a combination of natural physical and chemical processes through the treatment marsh, is to remove algae, reduce biological oxygen demand, or BOD, and remove non-filterable residues, or NFR, ammonia, total and fecal coliform, and nutrients such as nitrogen and phosphorus. Then in tertiary treatment, the water from the treatment wetland is chlorinated for disinfection and then dechlorinated. The flow is either sent to the enhancement marshes for polishing or discharge into Humboldt Bay, with some cycling and exchange in these two flows. This is just one example of using wetlands for wastewater treatment. The following references were consulted in developing this video lecture.